Hi, I'm Larry Puckett, the DCC guy. Today we're going to go back and take a follow-up look at the subject of shorts because there were just a lot of questions that came up in emails and also in the comments. And I want to go back and try to cover some of those questions and give you some additional information that I hope will allow you to better handle the subject of shorts and the matter of shorts that might be occurring on your model railroad. So let's go ahead and get started with that. Now, one thing I do want to cover before we get started with this subject of short circuits is some announcements for you. And the first one deals with how you view my YouTube videos, because I've added a new feature to the videos. And that's something that YouTube offers now called chapters. And down here at the bottom, along the bottom of your video, where you have a horizontal scroll bar, I've set it up now so that it will be broken up into individual sections. And they're called chapters. So like the first one will be the introduction, and then we'll have maybe feedback and announcements, and then material covering the subject of hand for the day, and then the wrap up, and all that will be subdivided. So I've shot a quick little video here to give you an idea of how that's going to work. So as you can see from this video, as I move across the bottom of the screen with my cursor, you will see that there's an intro section, and then I move in to various other topics as we go through the video, ending on my far left, your far right, with the wrap-up. And at each point along the way, the cursor or the pop-up avatar in there will actually allow you to see what the subject is in text, and also you can see it visually, because it will allow you to basically track across the scroll bar and see what I'm going to be talking about. So that way you should be able to better decide which sections of the video you want to watch, and make it a lot easier than me providing actual timestamps for where you can go to pick off a certain part of a video. Okay, so that's the first thing, and I tried it out and it seemed to work on the sample that I did, so hopefully it's going to work on this video here as well. This will be the first time I've actually put up a new video with this in it, so hopefully it'll work for you. Okay, so let's go ahead and move on to the chapter on shorts. So hopefully you're following along here on the bottom and know what I mean by the chapters. So let's go back and review a little something about short circuits and what it means for DCC. When you have a short circuit on your track, it can cause two things. It can cause a voltage spike that can exceed the breakdown value for decoders. So you can actually blow a decoder, or it can actually make changes in CV settings in your decoder. Now, one of the things that can happen, and you asked me about, is the subject of runaways. And runaways typically happen because people have CV29 set to analog conversion. Analog conversion just means that it allows the decoder to operate on a DC-powered layout. And what happens is when you get a voltage spike, it confuses the decoder, and the decoder, applies the full 13 or 14 volts from your layout to the motor, and it just takes off. That can be very disconcerting to happen. So if you simply go into CV29 and change that and turn analog conversion off, that will prevent that from happening in most cases. Of course, the really bad thing about these voltage spikes is that they can actually kill a decoder, because they can greatly exceed what decoders are designed to be able to handle. But also, in cases where it's not lethal to your decoder, you can actually see the CV settings, certain CV settings, actually change in your decoders. So you might have a locomotive that stops responding to its address simply because an intermittent short changed the address or just wiped it out. So that's one thing you need to check. If it doesn't respond anymore, you might want to go back and check your CV settings. And that's where Decoder Pro comes in handy a lot, because if you've saved your decoder CV settings, you can simply rewrite them using Decoder Pro and get back to where you were. Now, in a lot of cases, though, what you might need to do is do a reset. And again, in most cases anymore, that is now changing CV8 to a value of 8. So just program CV8 to a value of 8, and it will reset your decoder to the factory settings for the CVs. So yeah, you can get large voltage spikes, and you can also get large current surges when you have a short circuit. So how does this happen? Well, one of the things that happens is boosters have large capacitors in them. And capacitors are, they're like big electronic batteries that store current. And when you get a short circuit, it's going to try to shoot out as much current as it can in order to meet that load demand. So it's going to try to dump everything it can out to the track, and that can mean excessively large current surges on your track. And that can be much greater than what the booster is actually rated at. For example, one of my electronic engineer advisors told me that he recently measured the output from a Digitrax DCS 100 command station, which has a 5 amp booster capability, and he was able to measure current surges in excess of 10 amps. And that's from a 5 amp booster. And that's because when you go into a short circuit mode, it just dumps everything out as fast as it can, trying to meet that load. And it's the same with the voltage spikes, because these voltage spikes can greatly exceed anything that decoders are capable of handling. Now, in addition to what this fellow measured with respect to the DCS 100, he also tested an NCE booster rated at 5 amps, and that one was capable of actually dumping, I believe it was 27 amps out onto the track. So you can get a lot of current, large voltage spikes from these boosters and their components. In addition to that wire, the wire itself in your DCC power bus can store a lot of current as well. And it can actually contribute to these voltage surges and current surges on your model railroad. So there's a number of factors involved in this that come into play. Now, in addition to the voltage spikes and current surges that can come from our boosters and from the wires, there's also other factors like the motors that potentially can create a voltage spike as well during a short circuit. So there's a lot of factors involved in this. Now, in the responses to last week's video, I had 2 or 3 guys who came back with the usual statement that I've been using all of these products for 10 years, and I've never had a problem. Well, I always say that you need to add one word to that, yet. I've never had a problem yet, because I'm a firm believer in Murphy's Law. If something can happen, it eventually will happen, and you're probably living on borrowed time. And one thing I want to share with you is an article that appeared in the April 2022 Model Railroad Hobbyist magazine. And I want to thank Nick Santo of Nick's Trains, the maker of Decoder Buddies, for sending me this link. I had not seen this article before, but it deals in depth with this issue. And for those of you that think that it really isn't a problem, let me just explain in a nutshell what he found. Now, they had been having problems at the La Mesa Model Railroad Club in San Diego, where this fellow Roy Davis, who wrote the article, is a member. And he's a retired electronics engineer. And what he related was an experience they had at a recent operating session. And they are located in a museum out there in San Diego, and they operate the layout for the public 4 days a week, 5 hours a day, and they run trains hard. Well, in this one example operating session, he said that they lost 7 locomotives, 5 of them due to decoder issues. And 3 of them were permanently damaged as a result of short circuits, either locomotives that derailed or that entered a turnout set against them, thus creating a short circuit that way. And that was 3 locomotives where the decoders were burned. In addition, the other 2 of the decoders that failed, it was due to CV programming being changed, and they had to reprogram the decoders before the locomotives would operate again. So it does happen, and it will happen. So the solution that this fellow, Roy Davis, came up with was to use something called a TVS diode. That's a transient voltage suppressor diode. And these are a specialized device. They're readily available that he added to the decoders. And he initially put them on the input wiring. Eventually, though, after a lot of work, he found that the motor was creating a lot of the spike in his case, and so he ended up putting the TVS diode on the feed to the motor so that any spikes that were created by the motor would be filtered out before it came back to the decoder and killed it. So in his experimentation with these decoders and under these various conditions, he found voltage spikes as high as 35 volts, and these were coming as feedback from the motor itself, which is why he decided to put that TVS diode but on the motor feeds instead of on the track input feeds. Before we go on, I want to ask you to take a moment to subscribe to the channel. It's simple, easy, and free. All you have to do is hit that little red subscribe button, and when the little bell comes up, click on it and click all. Now, I will put the link for this article in the description so you guys can go take a look at it and read it. Also note that there is a large follow-up discussion on the Model Railroad Hobbyist Forum about this as well. And I will add a link to that in the description as well, so you can go read that. There's over 50 discussion comments in that thread. So take a look at that. I will tell you that a lot of it is very deep into the electronics. So take it with a grain of salt if you're not an EE or electronics engineer. Now, of course, adding a TVS diode to an existing decoder can be a little tricky because it can require some additional soldering to a circuit board. However, I've added a link to a video here by Nick Santo that will show you how you can add one of these TVS diodes to one of his decoder buddy boards. So take a quick look at that for some hints and tips on how to get that done. Now, one thing I want to go into next is some things that you can do to try to short-proof your model railroad and eliminate some of these issues before you end up paying for new decoders. And the first one would be the auto reversers. So what can you do instead of using these auto reversers that depend on the short circuit generated in a reverse loop to change the polarity? What can you do? Well, one thing you can do that won't do that is use the contacts that are built in here to your tortoise switch machines to actually create a reversing switch, because these are basically a double pole, double throw switch. And you can wire these up so that it will reverse the polarity for you for the actual reverse loop when the switch is thrown. And remember, with DCC, you can change the polarity under a moving locomotive. It won't matter at all that it is moving. And you can set that up so that any time that this changes the position of your turnout, it will correct the polarity of your reverse loop for you. So that's very easy to do in reality. In addition to that, there are various other kinds of optical and magnetic detectors that can be used, as well as block occupancy detectors that you can set up so that they will control a relay, for example, and reverse the polarity for you. And I did a quick look on the internet, and there are a number of companies that make products like this for controlling the polarity and for setting up reverse loops that don't depend on any of these shorts being generated. And one company in particular that I ran across is a company called Azatrax, AZATRAX.com, and I'll put that in the description as well. And right there they have a section in their website about reverse loops and how you can automate them. Take a look at that. They use, I believe, an optical detector system. So go ahead and take a look at theirs. And if you do a search on the internet for reverse loops and model railroad reverse loops, I think you'll find that there are a number of companies making similar circuits to automate reverse loops that do not use the triggering effect of a short circuit. okay, like an AR1 and similar types of devices do. Now what about handling the polarity-related shorts that occur at frogs? Now in the video last week I talked about how frog juicers and the frog AR and similar devices are dependent on the short circuit created when a locomotive's wheels hit a frog that has a polarity mismatch with it, and it automatically corrects it for you. Now one thing you can do is use a turnout switch machine like this DCC Concepts IP Digital that has a polarity reversing circuit built into it, so that every time you throw the turnout switch machine, it will correct the polarity automatically for you. The tortoise switch machines have 2 single-pole double-throw switches built in, and each of those can be used to control the polarity of a frog, so that you can control the polarity of the frog, correct it, and not create any short circuits in the process. So those are the 2 primary methods that I would suggest, and I've shown you how to do that in prior videos. Now another approach that I'm planning to test out here on the Piedmont Southern with the limited number of frog juicers I have is to actually pull those frog juicers out and leave the frogs dead. Because in the past I've never really had that many issues with diesels, and my fleet are primarily diesels here, actually crossing these dead frogs, because they usually bridge it quite nicely and they're not going to die on you. The main problem you'll have is with short wheelbase diesels and steam locomotives. Steam locomotives, they seem to be just sensitive to it overall, and if you've got a dead frog, they're not going to like it in my experience. But one thing you can do is put a stay alive in locomotives that have a hard time getting across dead frogs. So if you have a couple of special situations like I do, such as my double crossovers and my gantlet track frogs, I can probably get by without using frog juicers on all of those. And in yards where I've got small switchers, I can probably install stay-alives in those locomotives to get them over those dead spots. So that's always something you can think about doing, is stay-alives are great to get you over dead frogs, and you don't have to worry about those shorts anymore. Okay, now let's move on and talk about the problems with circuit breakers and how we can eliminate that issue, because the circuit breakers are really there to protect your layout once a short circuit occurs. They then will shut off power, but they keep trying to reestablish power to the layout. And so you get that series of small shorts. Each time that they reconnect, you can get another short, and then they kick out, and then come back on in another second or two, and then kick out. So you get this repeats. And as I said last time, you can take the manual reset option, and that involves, typically on most of these devices that offer it, having a push-button switch connected to contacts on the circuit board, that when the circuit trips and cuts power off to your layout, or to the block that particular circuit board is protecting, it will not restart. It will not attempt to reconnect to the layout until you hit that push button. And that way you're not going to have this series of little spikes, one after the other, due to the system trying to reestablish power. So that's one thing you can do. Now another thing, and I mentioned this a little bit last time, but I want to be more explicit about it. The DCC Specialties PSXX circuit breakers are specially designed, and they have 2 things built in. First of all, they have these TVS, transient voltage suppressor diodes, built into the board. So they will clamp down the voltage spikes before it ever gets to your layout. So that's one thing that you can do to prevent those voltage spikes from creating problems with your decoders on your layout. Another thing that Larry Meyer built into those circuit boards is a current limiting capability. So if you've got a situation where you've got a booster that can put out 10 amps in a short or 25 amps in a short, like the NCE can, what you can do is use the PSXX device, and in a short circuit, when it detects a surge of current coming from a booster or wherever heading towards your track, it will automatically go into a circuit that will reduce it to the amperage that you have set for the trip current. So if you set the trip current for 2 amps, it will not let anything more than 2 amps go through to the track when a short occurs. So the PSXX circuit breakers are the only ones I know of on the market today that have this capability of eliminating these excessive voltage spikes and also preventing the current surges from exceeding the normal operating value that you've already set. And think about that when you're going to be installing a circuit breaker on your model railroad. Now, someone else asked me about how effective are RC filters, the resistor capacitor filters, also known as a snubber. And I've shown you how to build these in the past and how to install them on your model railroad. And these are also available in ready-to-use form from NCE and also from DCC Concepts. So those are readily available. You can just basically wire them into your DCC power buses, and they will take care of voltage spikes. They won't do anything about your current surges, but they will eliminate the spikes. Well, that's a wrap for today's video. You know, I've thrown out a lot of information to you in this video, and hopefully it wasn't more than you were able to absorb. But if you want to, come on back and rewatch the video and the various chapters that are significant to you. But don't ignore it. It's not a situation that is going to go away, and it's something that, as I said, if it can happen, it eventually will happen, and it might happen to you. And you don't want to be blowing these expensive sound decoders and the like. But again, take a look at that article that I provided the link for in the description to this video, and take a look at that thread on the MRH forum about the TVS diodes, because I think they're an interesting thing. Unfortunately, because they do require soldering components onto a decoder, you might run into issues there if you're not very good at soldering. But as I said, there are ways up front, though, that you can try to prevent these shorts from happening and therefore eliminate the potential loss of your decoders. So, have a great week. Have a great weekend. We'll see you here on Monday with UK Monday, and then next week with another video from the DCC Guy. Bye now.